Oh, you got 2-1 functions and continuity. Okay, like I said, it's a lot more conceptual based versus number manipulative. Alright, so a lot of concepts in this one. Everybody almost good? So moving on. Next slide. Alright, summarize. Okay, now a function. Now this is from yesteryears. Okay, so this is where we got to do some recalling. A function is a relation in which each element of the domain is paired with exactly one element of the range. Okay? Now, to know that, we got to know two more words that are in there that the book just thinks you know. Domain and range. Domain are x values. It's a fancy way to say x's. Okay? Range are y values. So domain and range are just fancy ways to say x's and y's. Okay, that's all they are. Now, all functions map. Mapping is a fancy word to say just doing, okay? So don't worry about that part. All functions of map elements of the domain to elements of the range. Basically what that means is every x has a y. Okay, that's it. Like think of a line, right? Each x coordinate has a y coordinate, right? Makes sense, okay? So each x has a y. That's all that says. Okay? What's going to change today is how they're paired up. Okay? So what they're going to start throwing at you in this chapter, in this lesson, is different situations where the way the relationships of these numbers can vary. Okay? And what types of relationships those are, and what they're called. Okay? That's all we're talking about today is relationship of numbers. Okay, that's it. What's going to be different and odd and new is how those relationships are talked about and how they are defined. Okay? And that's what the next few slides are talking about, alrighty? So, there's going to be some new terms, new turbot, new verbiage. Alright, it's going to seem weird, you just kind of have to go with it. Okay, and really understand it. Really replace domain and range with x and y, and I think it makes a lot more sense. Okay? Probably the biggest thing to get through these next few lessons, next few days. Replace domain with x, replace range with y, and I think it all makes sense. Okay? Alright, so here's your two types. Alright, the first type, and the first weird new verbiage kind of, is called a one-to-one function. Okay? It's called a one-to-one function. It's where each element in the domain pairs to one unique element of the range. Alright, now I just want you guys to write down this definition. That's it. I don't want you to write this mapping just yet. Okay, just write this part down first and then we'll talk about it. Alright, I'm actually going to put everything up there though, just to make it all make sense. Okay? So I want you guys to write the top halves first. Okay, one-to-one. Each element of the domain pairs to exactly one unique element of the range. That is a one-to-one function. Now, to be called what they call an onto function, which I think is the weird sounding one, an onto function means that each element of the range corresponds to an element of the domain. Alright, now take those two definitions and throw out domain and range and put in x and y. Alright, so one-to-one. Each element in the x's pairs up with one unique element of your y's. Okay, what's unique mean? Different. You're different. You're unique. You're not the what? You're not the same. Okay? So that means to be one-to-one, each x has to be to a different y. Okay? Now, notice what word is not in the definition of onto. Starts with the U. Unique. Okay? So now this is where the book gets a little confusing, I guess. Look at this box. Okay, they don't even put the letters in order. What a bunch of jerks. Okay? See how your range has D, B, and C in it, right? Okay? And see how these arrows are like partnering up with these numbers in your X's, right? Your domain. Okay, so your domain has 1, 2, 3, 4. Your range has D, B, and C. Your X's are 1, 2, 3, 4. Your Y's are D, B, and C. So to be 1-to-1, each X has to go to a unique Y. So 1 goes with D, that's cool. 2 goes with B, that's cool. See how 3 and 4 both go with C? See that? Okay, that's why you lose your 1-to-1. Okay, because it's not unique anymore from your X's to your Y's. But everybody in the Y box, in your range box, has a buddy over in your X box. See what I did there? Yeah, okay, cool. Alright, in your domain box. That's what makes it onto. Okay? See this one over here? See this C? See how he's all by himself? He's all alone. That means since he doesn't have anybody and he's in your Y's, that's what makes this one not be 1-to-1. But 1, 2, and 3 don't buddy up. D, B, and A. See how they each have a unique partner? That's how they have. That's why they're 1-to-1. 3 and 4 both go to C, so they don't have a unique partner. Okay. I think the letters and the mappings of it makes it a little confusing, a little messy. All right. Once we go to start throwing numbers in there, I think it makes it make more sense. Okay. So don't draw these maps just yet. We'll come back to them if I want you to. Okay. Everybody good? Fantastic. Moving along. The last one is when they're both. Okay. Write the top part. Don't write the box. Okay. When you're both, each element of the domain, meaning your X's, pairs to exactly one unique element of your Y's, and everybody in your Y's has an X value that goes with them. It's the easiest one. It looks like that. Four on the left, 4 on the right, everybody with their own partner. Clean as that. Alright, now while you guys write this down, I'm going to ramble for a little bit. Okay, so kind of half listen, half right. Where this is going to go, here to start, is you're going to be given a table or a graph of points. Okay? But remember where this all goes back to. Domain and range are X's and Y values. Okay? You remember that, you got a good shot of getting this and understand this. Okay? If you don't remember that, you got no shot. Sorry. Sorry, not sorry. Hashtags. Okay? Because you have to understand what these words mean. Domain is your X's, range are your Y's. Okay? You also have to kind of understand, and we'll get to this, what a function is and what a function can do. Okay, once you get it to graphing. Alrighty? Okay, so here's how you should handle this. Here's how you make one of those boxes, which is called a mapping. Okay? State the domain and range of each relation. Then, determine whether each relation is a function. If it is a function, determine if it's a 1-to-1, onto, both, or neither. A lot of words, a lot of things. Okay? Here's what you do. The first thing we're going to do is going to make a box. Boom. And for now, I'm going to label it X. It's my X box. Okay. Now, I'm going to go through here. See how these are ordered pairs? See right? See that? See how it's a group of ordered pairs because it's in like a little set thingy? Okay, so that's a group of ordered pairs. So I'm going to go through here and I'm going to take my X's. So -6, -5, -3, -1, +6. And I'm going to write them in my X box. Okay, see how I did that? Took all my x values, put them in my x box. There's my domain. Right there. Domain is a fancy word for your x's of a group. Okay? That's my group, those ordered pairs. I picked out my x's. Alrighty, now over here to the right of that, does that make sense? Everybody good? Okay. Now over here to the right of that, I'm going to draw another box. For now, I'm going to label that my y box. Now I'm going to do the exact same thing, except this time I'm going to take my y's and write them. Okay. Now the cool part about this, you don't have to write repeats. Okay. So -1, -9, -7, +7. So see how -9 happens twice? Happens right here. There's your y's, and it happens over here as another y. Okay. Once that happens, you don't have to rewrite it. Okay? Now, your y's, you need to write this down someplace, make a note. Y's can repeat, x's cannot. Y's can. Y's can repeat. Y's can repeat. X's cannot. Alright? If your x's repeat, you do not have a function. That's how you know. Okay? See how it says determine whether each relation is a function or not? That's how you know. If your x's repeat, it's not a function. I think the next one's like that. Okay, so you'll see that. But that's the only way it's not a function. Anything else you guys see will be a function. Okay? So, do the x's repeat here? No. So is this a function? Yes. Fantastic. Okay, function? Yes. So question number 1. Is it a function? Why, yes, Mr. Mormon, it is. Question number 2. If it is a function, determine if it is 1-to-1, onto, both, or neither. To do that, you got to do the little arrows that they've been doing. Okay? And the way you do the arrows is you partner them up like what they are with the ordered pairs. See, this is just a fancy visualization of this set right here. Okay? So you just draw from, since -6 is -1's buddy, right here, see that? So you do an arrow, -6 to -1 like that. Alright? -5 to -9 like that. -3 to -7 like that. -1 to 7 like that. Okay? And then 6 up to -9 like that. Okay? Alright. Now, here's where this gets a little trickier. Does every x have a unique y? No. No. Okay? Not every x has a unique y. See how -5 and 6 both have -9 as buddies? That's where you lose your uniqueness. So you lose 1-to-1. Okay? So if it's one, is it 1-to-1? No. Okay? And that's knowing the definition of what 1-to-1 is. Alright? Now, is it onto? Yeah. Okay? Onto is that every y has an x. Okay? Doesn't matter if it'll say one y could have all, like you could have 5 x's and 1 y. And that'd be okay. Okay? Onto just means that every y has an x. Okay? So yes, this is a function. And it is onto. Okay? Listen to me very carefully. Very rarely do you have something that is a function and not onto. Okay? It'll have to be almost forced upon you. Okay? Like I'd have to make it so. Alright? If it comes like in ordered pairs like this, it'll be onto. Most things are onto. Okay? as long as they're functions. Does this one make sense? Okay, next one. Okay, so it's now see how they can give it to you in different ways. The first one, they give a couple of them, they give you some maps straight up. All right, a couple on homework, you'll have the maps already mapped out for you. Okay, that's the ones that you'll have to be careful with. All right, the ones that they just give you the maps right away, that's where they can do some funny business because then they're just throwing numbers in there. Sometimes they'll give you tables, like this one, okay? If they give you tables or if they give you ordered pairs, as long as they are functions, chances are they are onto, okay? Like almost 99% of the time they'll be onto if they give you tables or ordered pairs, as long as they are functions, okay? So my advice is always, at least until you get the hang of it and understand what you're looking at, I always make them 2 boxes. My X box, my Y box. And I line up my X's. Now once my X's repeat, so 2, -1, -2, and then I go -1, -2. See how I have repeating X's? Everybody see that? Then I know right away if I go back to the first one and do those same questions, it's not a function. Okay? The second you have repeating x's, not a function, you're done. Okay? Split second. Not even like 2 seconds, the split 1 second, 1/2 second. The second you have repeating x's, not a function. And you don't have to do the rest of it. You don't have to worry about the rest of the questions. Because those questions depend on you actually having a function that you're working with. Make sense? Everybody good on that? Fantastic. Moving along. All right. Boy, those look funny, don't they? Back up. Look at me. Let's see. We got points of what? -3, 2. Is that right? Yeah, it looks right. Let's see. -2, 1 is right there. -2, -2 is right there. See that? Okay, let's see. -1, 1's right there. Anybody know the answer to this one yet? Yeah. It's not a function. Why, Mr. Savannah? Where'd I hit at? My -2 repeats. See how this is -2 on the x? See how this is -2 on the x? See that? Okay. So once there's repeating, right like that, see that? You can just go ahead and stop with whatever you're doing. Not a function. Okay? So just be careful, okay? You don't have to do, if it's not a function, you don't need to do the box. Okay, if you determine it's not a function right away. Okay? Now, this last one here that we're going to do, this 1B right here, I'm going to circle it in blue because it's important. All right? It's one like this that they can really force some funny business on you. Okay? It's one like that they can really do whatever they want to do to you and make it weird. So you have to be careful with what you're doing and understand how to do this. All right? First thing you look at, you make sure that no x's repeat. -3, -2, -1, 0, 1. Okay? So no x's are repeating, which means it is a function. We're good there. Okay? Now, same questions apply. Determine whether it's 1-to-1, onto, both, or neither. Okay? So if it's 1-to-1, that means every x has a unique buddy. Every x, unique y. Is that the case? No. Because it looks like -1 and 1 are both going to what? 6. See that? On the x's from the left, where it says domain, right? Take out domain and range, put an x and y. -1 and +1 both go to 6. So it's not 1, 1. Okay? Now, is it onto?
Yeah.
No. Because not every y has an x. See? Okay? So that means it's not onto either. Which definitely means it's not both, which means this one is. Technically, it's neither. Okay? It's neither. This one is very rare. Okay? And like I said, this one will have to be forced upon you. Okay? I will have to give you the math. There's no rhyme or reason as to where those numbers come from, because in the real world of mathematics, that would never happen. Okay? Because your y's come from your x's. So if you have an x, you're going to have a y. It may be a repeating y, but you're going to have one. Those are rare. Okay? You're almost always at least onto if you are a function. That's the one case where you're not. Okay? So just be on the lookout, because that's a weird one. Okay, okay? Let's see what's next. We're going to skip vertical line test. Okay? All right. 2 more definitions. I'll also owe you the vocab sheet. I'll get that up to you today. Okay? There will be vocab on that quiz, so be ready for that. I'll do that today during ISS and preps and stuff like that. These 2 definitions. The first one, discrete relation. It's a relation in which the domain is a set of individual points. I'm going to back up real quick. Okay? This would be a discrete. This would be discrete. These 2 would be discrete. Okay? It's just when you have individual points, basically. Okay? Individual points. Okay, so just discrete's what we've been working with, where it's just a point here, point there, points everywhere. Okay? Now, continuous is something that we had been working with. Okay, a continuous relation is when the domain, the x's, have an infinite number of elements. Infinite means what? It goes on and on and on and on. Don't stop believing. Infinite means it goes on and on forever and ever, amen. Right? So that means there's an infinite number of x's. Alright? And they can be graphed. Once you graph those, right, it's becoming a line. So we've done that before. We've graphed a line. Yes, you have. I know you have. I saw you do it on your test. Okay? Lines are functions. Everything that we're going to work with after this chapter, okay, some weird stuff, some curves, they're functions. Okay, backing up one more time real quick. This guy right here, anybody know what this is called? Starts with a P. We're going to work with him in 2 weeks. Parabola. There you go. Okay, that's a parabola. It's a function. All right. Anything. This is where the vertical line test comes in. If you draw a fake vertical line, if it only intersects at 1 point, it makes it a function. Intersects at 2 points, not a function. Okay. So that's how you know whether something's discrete or continuous. Discrete's a set of points. Continuous is just as it sounds. It's continuous. You draw it continuously. It goes on forever and ever, both sides. Okay? There you go. Okay? You don't really need a graph if you can determine the domain and range. Okay? Then determine whether the equation of a function is a function, one-to-one, onto, both or neither, blah, 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 blah. Doesn't have to be a fancy graph, okay, but you need to make sure you get the gist of it, right? Okay, let's see if I have, let's see, black. There we go. Bam. Ooh, I know what I want to do. Hold on. Oh, yeah. Whoops, that was terrible. Let's try that again. There, that was still terrible. There we go. Much better. Okay, so here's how this works. I'm going to go ahead and graph 1 half x minus 3 just really quick, okay? Let me get a third color here. Let's see, minus 3 would be about there. Up 1, right 2, so it would go about, yeah, something like that. Good enough for now. Okay? Now, the red is my line, right? Do you see that? Okay? Number 1, function. Yeah. Okay? It's a function. It's a line. Okay? Most of these will be functions that you graph, okay? Determine the domain and range. Okay? Now, that means your domain is your what? Your x's, right? If domain is your x's, now, since it's continuous, see how it's a line? Okay? And lines keep going on what? Forever. Okay? That means this is my x-axis here in yellow, right? That means this x-axis keeps going on forever and ever. Out here, this way. Okay? Now, if I'm way out here, is there still this x value that's somewhere on that line? Yeah. Okay? It's way up there by now, but it's there. What about out here? Still, right? What about out here? Still? Okay, so you get the point. No matter how far the x's go that way, you still have x's on your line. What about this way? Yeah. Okay. Still got x's. They're down there now, though. But that line keeps going on and on, right? Forever. So my domain all real numbers. Okay? That's thinking about it horizontally now. See how it keeps going on horizontal, keeps going on horizontal this way for your domain since your x's? Make sense? Okay? Now your range is your y's. Whoops, didn't want to write that. Does your line keep going on and on this way? Same concept? Yeah, it's going up. Okay, it's going up and right, and it's going down and left. So it's going on forever and ever. So your domain is all real numbers. Okay? Now, here's where this gets just a little trickier, okay? That's all, well, here, let's do it like this. That's all I want you to do with these, okay? Graph them, state domain, state range. That's all you got to do, okay? Makes sense. Okay, cool. Let's see what's next. I think I'm going to skip, nope, I'm not, okay. We're going to skip this part, though. We're just going to do this, all right? Because I think that makes it harder. Okay, blast from your freshman past. Function notation. Okay, given f of x equals 2x squared minus 8, find each value. F of 6 and f of 2y. Now, at some point in your careers, someone probably told you this is like a machine, right? You put numbers in, you get numbers out. Remember that? Okay? I don't like that analogy. I really don't. Okay? I think that it's more like, I get the machine analogy, but it's more like an instruction manual. Okay? I'd say the f of x tells you what to do, and then down here tells you what you do it with. Okay? So up here, it says we're going to take some x value, we're going to square it, double it, subtract 8 off of it. That's what this function does. right? That's the instructions. Squares it, doubles it, takes 8 off of it, because that's the order of operations. See that? Now, for this first one, what number are we going to do all that with? 6. Down here, it tells you what you do that with. Okay? See my difference? I'm not trying to sound conceited, but I like my way better. Okay? So, f of 6 means we're going to take 6 instead of x. And then after you do that, we're just going to do this right side, right? This left side tells you what to do. The right side's what you do. You do it. Okay? Here's where you have to follow your order of operations. So exponents first, right? So you're going to square 6. So 6 squared is 36. And then we're going to double 36, which would be what? 72. And then we're going to take 8 off of 72, which gives us 64. Done. Okay. I like the instruction manual example myself. Of course, I'm biased. Okay. This tells you what you're doing. This tells you what you're doing it with. Okay. Now for the second one then, same function, right? F of x equals 2x squared minus 8. So that's still what you're doing, but this time you're doing it with what? 2y. Okay? So now that's where things change just a little bit, because now you have 2y instead of just a number. So you have 2 parentheses, but 2y still goes in for x minus 8. So over here, when we did 6 squared gives you 36, how'd you do that in your head? 6 what? 6 times 6, right? Okay, so over here, do the same thing, but do it with 2y. So what's 2y times 2y? 4y squared, right? Make sure you get those y's also. So 4y squared. Okay? And then what's 2 times 4y squared? What? 8. Yeah, a little bit, a little big. You're thinking, yeah, 8y squared. So 8y squared minus 8. Are those like terms? No, they're not. So you're done. All right, page 91, 92, 14 through 19, 32 through 34. You have a lesson check to Wednesday over this, okay? So make sure you do this homework. Remember, lesson checks are what? Wednesday, but you can use your notes, open notes. All right? Cool? Cool.